All right, this is lesson 11.5. This is a real quick one. It's called the area of similar polygons. And we've talked about area of similar polygons before, and we've said that if we know the similarity ratio, remember similar polygons have a similarity ratio, then their areas are squared. So if you look, the theorem 11.1 says that if two polygons are similar, then their areas are proportional to the square of the scale factor between them. Remember that scale factor is the same thing as the similarity ratio. For example, if this had a side measure of 2, and this was 4, and this was 6, and this was 12, remember when I compared the sides, I would have 2 is to 4, and 6 is to 12, and the similarity ratio, or the scale factor, is 1/2. The small compared to the large is a scale factor of 1 to 2. That means that their areas are the scale factor squared, meaning that their areas are going to be at a ratio of 1 to 4. Okay? That's all you're doing in this lesson. So let's look. It says that it's rectangle ABCD is similar to rectangle PQRS. So first thing that you need to remember is that we never give the shapes in the exact same order. So AB, this side right here, this is a rectangle, is proportional to this measure right here. Okay, so 6 is to 9. Well, the first thing I want to do is reduce that. That's the same thing as a ratio, a similarity ratio of 2 to 3. Okay, so I know that they have a similarity ratio of 2 to 3. Now I need to find their areas. Well, the first thing I have to do is to find the areas. I have to square that similarity ratio. 2 over 3, this one is squared, equals 4 over 9. Okay, the next thing you see is that the area of the smaller shape is 48 square inches. Here's my similarity ratio for my areas. So 4 over 9, which is going to set up a proportion, is equivalent to 48 over x. I need to find the area of this shape. Well, how do we find a missing value in a proportion? We just cross multiply. So I end up with 4x equals 432. I'm going to divide both sides by 4 and find out that x equals 108. So the area of PQRS equals 108 inches squared. Okay, remember your range, your similarity ratio or scale factor. Okay? I have one more example for you. The area of triangle ABC is 98 square inches. The area of triangle RTS is 50 square inches. I need to find x. I need to find the similarity ratio of the sides. So the first thing I'm going to do is set up their squares. So if I call the first triangle, we'll just set up A to B similarity ratio. They're squared. The measures that I have are squared. 98 squared is going to go on the top. That's the area of square area. And 50 inches squared is going to go on the bottom. I'm comparing these two. Well, the first thing I want to do with any fraction, I would like to reduce it first. I'm going to divide these both by 2. Oh, and when I divide by 2, look what fabulous things happen. I have 49 over 25. Remember, that represents the similarity ratio squared. find out what the similarity or scale factor is, I would take the square root of these, right? Whatever you do on one side, you must do on the other. So the similarity ratio is actually going to be 7/5. Again, I'm going to set up a proportion. So using the similarity ratio of 7 to 5, and if the larger triangle has a side measure of 14 inches, and I'm trying to find the smaller x. How do I solve for proportion? Cross multiply. 7x equals 70, x equals 10. This has a measure of 10 inches. Not square, sorry. So 10 inches. Right? Okay. That's all I have for you.